In this video, we're going to talk about what happens when you have two parallel lines cut by a transversal. And there's lots of definitions and drawings that go along with this, so make sure you have your paper ready. So the first thing we want to talk about is parallel lines. This is two lines in the same place that never intersect. And actually, it can be more than two. So really just lines that never intersect. They're going to keep going forever, but never touch. A transversal is a line that intersects two or more lines. So if you'll notice, I've drawn my parallel lines and then I've drawn this diagonal across it. That's what we refer to as the transversal. Congruent angles. We've talked about these before. Angles with the same measure. So if we drew them, they're going to match. Corresponding angle. Any pair of angles that have the same relative position on each intersection where a straight line crosses the two others. We say they have the same location on a different figure. I always say, your left ear and your neighbor's left ear are in the same place, but they're on different figures, so we call them corresponding. And if you look here, angle 1 and angle 2, they correspond because they're in a different place, but they're on a different figure. Or same place on a different figure, excuse me. All right, alternate interior angles. Non-adjacent, meaning they're not beside each other, interior angles that lie on opposite sides of the transversal. So here I've got my two parallel lines. I have my transversal. My alternate interiors are going to be those that are in between the parallel lines but on opposite sides of that transversal. So this 1 and 2 would be alternate interiors. This angle and this angle are also examples of alternate interior angles. Okay, alternate exterior angles are non-adjacent exterior angles that lie on opposite sides of the transversal. So much like our alternate interior angles were in between the two parallel lines, our exterior angles are on the outside of those parallel lines, also on opposite sides of the transversal. Okay, then we have same side interior angles. And these are angles that lie on the same side of the transversal between the other two lines. So again, these are interior, they're on the inside. They're between our two parallel lines. This time they're both on the same side of that transversal. So same side interior angles. So here I kind of drew an example of our two parallel lines cut by a transversal, and we get all these angle relationships. So here's our parallel lines, there's our transversal. Up here, angles 1 and 2, angles 7 and 8, they're all exterior. But inside 3, 4, 5, and 6 would all be interior angles. And then whether or not they're same side or alternate sides, you need to decide based on where they're located in that transversal. All right, some important things you need to know about these types of angles. Alternate exterior, alternate interior, corresponding, and vertical angles, they're always congruent. So if you have a set of alternate interior or alternate exterior angles, those two angles are congruent to each other. Vertical angles are congruent, you already know that. And then corresponding angles, remember those are the ones that I compared to ears, are also going to be congruent. Okay, same side interior angles will be supplementary. The more you look at it, that will start to make logical sense. But if they're on the same side of that transversal, the two angles are going to be supplementary. All right, and then all linear pairs are supplementary. That's not new. You should have already known that. Okay. So let's identify some angles. Here I have my two parallel lines cut by my transversal. So if I want to identify my alternate exteriors, I would say 1 and 8. Also 2 and 7. These are my alternate exterior angles. So let's go the other way. Alternate interior. We got to look in between the two parallel lines. So 3 and 6. And also angles 4 and 5. Okay, and what do we say about these? These two are alternate exteriors, so they're congruent. These would be congruent to each other, not all 4 of them. Angle 3 and 6 are congruent because they're alternate interior. 4 and 5, congruent. All right, let's talk about corresponding angles. So if I drew this little line and divided this into 2 separate drawings, we're going to look for the angles that are in the same place on different drawings. So 1 and 5 are corresponding. 3 and 7, 2 and 6, and 4 and 8. All are corresponding. What about vertical? 1 and 4, remember vertical are the kissing. 2 and 3. 5 and 8. And 6 and 7. And again, vertical angles are also congruent. So we have all these different types of angle relationships that we can determine looking at this. The only one I didn't identify is same side interior. So like 3 and 5, same side interior. And remember, unlike all of these, which are all congruent, these would be supplementary. Okay, well, so let's do a little application here. Why do we need to know these relationships? Well, we need to know these relationships and which ones are congruent and which ones are supplementary, because that way we can solve for missing values. So let's look at a couple of sample problems. So remember one, if measure of angle 2 is 75, what is the measure of angle 6? Well, 2 and 6 are corresponding angles. So if 2 is 75, then 6 is also 75. And consequently, we could say 2, 6, 7, and 3. 7 and 3 would both be 75 because 2 and 3 are vertical, and then 3 and 7 are corresponding, or 6 and 7 are vertical. All right, so let's erase that 75 so we can do this next problem. Measure of angle 3 is 2x plus 1. And the measure of angle 4 is 4x minus 1. Find x, and then tell the measure of angles 3 and 4. So first, to find x, we have to look at our relationship. Well, 3 and 4 are adjacent, and they're making a straight line. So that means they're going to equal 180 degrees. So we can say 2x plus 1 plus 4x minus 1 equals 180. Combine our like terms, 6x, positive 1 and negative 1 just equals 0, so 6x equals 180. Now, if we divide both sides by 6, we're just solving an equation. We find that x equals 30. So that's the first part of the problem. Then it wants to know the measures of 3 and 4. Well, angle 3 was 2x plus 1, so we have to plug the 30 back in. 60 plus 1, so angle 3 is 61. So 4 minus 1. 4 times 30 would be 120, minus 1, so 129. And if we put those together, we should see what did I just do? That it should equal 4 times 3 is 12, 120 is 119 actually. Alright, sorry, that's 119, not 129. We would see that this equals 180 degrees, which is what it should. So that's how you identify angle relationships when you have two pair of lines cut by a transversal, and the ways to solve problems based on those relationships.